afternoon, everybody. My name is Mr. Ansalamigwe. You are welcome to my channel again. Please, as you watch, try to watch till the end so that you capture everything that I'm going to teach. Today, we want to look at how to calculate using Hess law. Look at the question. It says, calculate the enthalpy change lambda H for the reaction. This is the reaction from the following data. These are the reactions whose enthalpy changes are already given. So what you are required to do is to calculate the enthalpy change for this reaction using the enthalpy changes from the given reactions. So in the first reaction, you see that the enthalpy change is -90, which means it's an exothermic reaction. Heat is lost along the line. Second one is also exothermic. Third one is endothermic. Now, how do we manipulate the three to get the enthalpy change for this overall reaction? What this means is that this overall reaction still exists here. It still exists here. If you check, you see that the species that exist in the overall reaction are still here. So we are going to take them one by one. This first reaction contains ammonia, but the overall reaction also contains ammonia. The difference is that the ammonia in the given reaction is 2 molecules and is at the product side, while the ammonia in the overall reaction is 1 molecule, but it's at the reactant side. So because of that, we are going to flip the first given reaction. We will flip it and divide the molecule by 2 so that we get 1 molecule. Not only this, we divide every molecule by 2 because of this. So let's go. We flip the first reaction and divide by 2. And that is 2 divided by 2. 2 ammonia divided by 2 will give us 1 ammonia. To yield 1 nitrogen divided by 2 will give us half nitrogen. Plus 3 hydrogen divided by 2 will give us 1.5. That is 3/2 hydrogen. The enthalpy change. Remember, because we flipped and divided by 2, we are going to flip the sign and also divide by 2. So -90 becomes +90 divided by 2, and that is +45 kilojoules. In the second equation, you will see that methane is at the reactant side of the overall reaction, but methane is at the product side in the second equation. And they are 1, 1, so no need of division, but we are going to flip because methane here is at the reactant and methane here is at the product. So we flip without division. Let's go. CH3 to afford CH4 to afford C plus 2H2. The enthalpy change will give us what? +70, no longer 70, so it's +70 kilojoules. We come to the third equation. Check again, you will see that hydrogen is at the product side and hydrogen is at the reactant side. Also, hydrogen cyanide is at the product side. So hydrogen cyanide being at the product side and also at the product side here means that we are not going to flip, but we will divide this one by 2 because it's 2 here. Hydrogen cyanide is 2 here and 1 here. So we divide hydrogen cyanide by 2 while it remains there. So we go. So if we divide it by 2, we also divide everything by 2. Hydrogen will give us, hydrogen divided by 2 will give us half hydrogen. 2 carbon divided by 2 will give us 1 carbon. 1 nitrogen divided by 2 will give us half nitrogen. and we are going to have 2 hydrogen cyanide divided by 2 will give us 1 hydrogen cyanide, and the enthalpy change is going to be plus 300 divided by 2, which is plus 150 kilojoules. At the end of the day, we are going to cancel out duplicate molecules or similar molecules. Check this. You see that we have half hydrogen here. We are going to remove half hydrogen from either here or here. This is 1 1/2. We can cancel half here and can remove half here. Remember, 3/2 minus half is going to remain 1. Remember that. Also, we have 1 carbon here that can cancel 1 carbon here. We have half nitrogen that can cancel half nitrogen. At the end of the day, we have nothing to cancel again, so we repeat what is remaining. Here we have ammonia and methane. If you check, what is remaining is exactly a copy of this first equation. So we rewrite CH4 plus NH3. There is nothing at the reactants. Okay, we have this at the reactant side, right? We have this at the reactant side. Sorry. At the product side also. So we have taken everything at the reactant side. Reactant side is finished. So we move to the product side. There's nothing here. There's something here. 3/2 minus half will give us 1. And we have 2 hydrogen here. So 2 hydrogen plus 1 hydrogen will give us what? 3 hydrogen. 3 hydrogen. Plus what is remaining at the product side is hydrogen cyanide. If you check this reaction, it is the exact copy of the overall reaction. Therefore, we now calculate the change in enthalpy of this reaction by summing every enthalpy we have gotten here, and these include plus 45 plus the next is plus 70 plus the next is plus 150. So when we sum this, we are going to get 45 plus 70. 45 plus 7, 5 plus 0 is 5. 7 plus 4, 11. So 115 plus 150. 5 plus 0 is 5. 5 plus 1 is 6 and the 2. So the overall enthalpy change is going to give us 265 kilojoules plus 265 kilojoules. And that is the enthalpy change of the reaction. Thank you very much.